Hey guys, Mr. B here again, bringing another math video. This video is my second in the logarithmic video series, so I just made the first one. In the first one I did an example of, well I actually did this example. Y is equal to sine x to the x. So this is the first type of question that I usually would use logarithmic differentiation on. So logarithmic differentiation, of course, is when I take the log of both sides, or actually I take the ln of both sides. So the other type of example, and this one is a function to a function. So that's the first type I use it on, and that's probably the most common question that I've seen anywhere that I ask on calculus assessments. The other type is when you have something that looks extremely complicated. So let's just make up an example. So y is equal to sine of x times e to the x, all divided by x to the 7 times ln of x. So if you look at this guy, it's a quotient rule overall because we have functions divided by each other, but in the top part of our numerator we have product rule, and in the bottom part we have a product rule. So this looks extremely complicated. So it would take a lot to be able to do this derivative. So a lot of times it's easier to do this with logarithmic differentiation than it would be to actually use our standard derivative rules. So what we do is we take the ln of both sides. So the reason why I use ln is because the derivative of ln of x is easier than log. So the derivative of ln of x is 1 over x. So that makes it easier to use because we'll be doing a lot of, it's called logarithmic differentiation for a reason. We'll be doing a lot of derivatives that involve logs. So I take the ln of both sides, and then I'm going to use my logarithmic rules to be able to simplify this. So I have ln of y is equal to ln of this entire thing. So it's sine x. A lot of my students, when they look at this, they say, oh my god, I'm never going to be able to do this, but it's actually quite a thing of beauty. It's almost like an art form when you start working these out. It's really a sense of satisfaction working at these big complicated derivatives. So the first thing we have to recognize is that when we're dividing things inside a log function is the same as subtracting log function. So that's our first rule we're going to go to. So ln, and then we'll have sine x e to the x minus ln x to the 7 times ln of x. So that's the first thing I do, is I use my rule for dividing things inside a log function, so we subtract. And then since we're multiplying now, we have functions that are multiplied together, we're going to use that rule. So we're multiplying things inside a log function, we add them. So the only thing we have to be careful of is this subtract symbol right here, so we're going to use brackets. So ln of y is equal to ln of sine x plus ln of e to the x, so we separate it with a plus sign, and minus, so add some brackets around this thing, and ln of x to the 7 plus ln x, just like that, and then an end bracket. So now what I need to do is use my exponent rule for when I have exponents inside a log function, we can take it out and multiply the log. So I have ln of y is equal to, and then I'm going to get rid of all my brackets as well when I'm doing this. So ln sine x plus x ln of e minus 7 ln of x, and then plus, well, sorry, I got rid of my brackets, so this is where people make the mistake, and I almost did it, is that this minus applies to both, so these are both subtract, ln of x. So now at this step, what I need to do is I need to take the derivative of all this. So normally what I would do is I would rewrite this step, but I don't have a lot of space. So what I'm just going to do is I'm just going to put brackets around this entire thing, because I want to show the person that's correcting my test that I'm actually going to take the derivative. So I take the derivative and I write d over dx. So normally I would do that in two separate steps, like I would put a bracket around this and then a bracket around that. I just don't have the space. So I got to take the derivative of each individual thing that's here. So generally the only rule you should use is the chain rule and the derivative of ln. So stuff usually works out pretty good with this. So we'll keep that in mind. All right, so let's go ahead now and start working this out. So the derivative of ln of y, this is actually implicit differentiation. So it's 1 over y, and then we got to remember to tack on that y prime afterwards. So that's like the chain rule. It's like ln of u is 1 over u times u prime, no different than it was y. And then I have the derivative of ln sine x. So remember, the derivative of ln is up here. It's 1 over x. So the derivative, if I can speak English here tonight, is 1 over u times u prime. So I can come down here, and I can rewrite this as 1 over sine x times the derivative of sine x, which is cos x. And then plus, so this usually works out pretty good. So the derivative of this guy, so ln of e, that's actually 1. Those are, you know, the bases are equal because log base e is the same as ln, so that works out to be 1. And then you have the derivative of x, which is just 1, minus derivative of ln of x, that's 1 over x, so 7 over x, minus ln x, so the derivative of ln is 1 over ln x times the derivative of ln x, which is 1 over x. So there we have it. We've taken the derivative. So now all we need to do is sort of tidy this thing up. So we don't leave this y on the bottom here. What we do is we multiply everything by y. So I just use brackets and just tack it on outside there. So cos over sine is the same as cotangent x plus 1 minus 7 over x minus 1 over x ln x. So, and then end bracket. And then all I do is probably the most annoying part. I rewrite this guy down in front of where my y is to. So I have sine x times e to the x all over x to the 7 ln x, and then I just rewrite what's in the brackets here. Cotan x plus 1 minus 7 over x minus 1 over x ln x. And there it is, guys. That is it. That is another example of logarithmic differentiation. I hope it helps you in your battle to conquer calculus, and thanks for watching, and I'll see you guys in class. Like, share, subscribe, do all that stuff. Thank you.